Hey YouTube, this is Jaren again with our next tutorial, and as promised in the last video, I was going to be showing you the difference between series and parallel circuits and how that relates to using a multimeter. I'm going to use this video later to prove that Ohm's law is actually working and that our calculations are important within a circuit. I'm also going to show that you can determine the relative brightness and stuff of LEDs as long as you do the math beforehand rather than just spending a lot more time plugging and playing different components by trial and error. So what you're going to need for this particular project is just a multimeter and something to test multimeters with. I don't care if it's LEDs like I've set up or if it's incandescent bulbs. You should be able to see voltages and currents throughout your circuit either way. So let's look at the board really quick and let's talk about series and parallel circuits. So as you can see, every component relative to the battery is in series with one another. Essentially, input of one, output of one, input of one, output of one. Just they're linked together in a serial fashion. The output of one links to the input of the one, links to the input of the other, and then vice versa and so and so. There are certain disadvantages of the circuit which I will have my sister take over the camera and I'll show you in a minute. The second most basic circuit you have is the parallel circuit. Relative to the battery, both inputs are wired together and then both outputs are wired together and then through a resistor. And essentially what this does is it means you can remove one and the other would still be lit, or you can do vice versa. And I'll again show you that with my sister in a minute. Okay, so we're just going to get right to it. And I'm going to show you what I have on the breadboard here. On the breadboard, this isn't in macro mode, so you're just going to have to live with me. On the breadboard, I've set up a series circuit here at the top, a parallel circuit here at the bottom, and then on the other side I've set up a combination circuit with one resistor in series with one LED within series with two parallel LEDs. And I'll show you the advantages and disadvantages of each of these circuits. The next thing I have out here is my analog multimeter, just because I want you to see the swing, not necessarily numbers for now. Okay, so Asley's going to take over the camera. She's going to point at what I point at, and that's going to be that. Got it, Azzy? Okay, put that around your wrist so it stays out of the picture. Okay, so what I'm going to do now is I'm just going to show you the series circuit, and I'm going to show you what its advantages and disadvantages are. So as you can see, both LEDs are lit up relatively the same brightness, but here's the issue with the series circuit. Oh no, the bulb before the second bulb broke. It won't light up anymore. So this is a situation where you kind of got to take the good with the bad. In series, you can add batteries together, you can add voltages together, you can add resistances together, and it's a great way to get different values. But if one component fails in the series circuit, so does the other. And you also measure current in series, which I'll show you in a moment. Okay, so the next circuit that I'm going to show you is what's known as a parallel circuit. The two anodes of these are linked together, and the two cathodes of these are linked together, and then back to ground, as seen in the schematic above. So when I turn these on, they're both relatively the same brightness, and that's a positive. Asley, can you come over it a bit more? Now, what's interesting about this is you'll see a slight change in brightness, but the other LED actually won't turn off if I remove one or the other. So that one's still running, and this one's still running. The reason for this is power isn't actually dependent on one going through the other to get to the LED. This is the reason why, like if you have a bathroom light with multiple lights, if one blows out, the other 3 or 4 don't blow out, because they're wired in parallel. So if one were to blow out, all the others wouldn't do the same. So the next thing I'm going to show you is a combination circuit, which I'm going to take this and she's going to go on the other side. The combination circuit has one LED in series with two parallel LEDs. So it's this circuit along with this circuit all in one. And you're going to be working with a lot of combination circuits, and this is kind of important to understand when you're troubleshooting. Because if you don't know what you're doing, then it gets really confusing. So same as all the others, if I remove one of the ones in parallel, then no biggie, it stays on. But if I remove the one that is in series with the two parallel, oh no, there goes 2 of 3 components. So again, you can see the advantages and disadvantages of each. Okay, so now I'm going to teach you how to wire in a multimeter, in which Asley is going to go ahead and take a quick look. You'll notice that I'm using red and black wires. This is going to be important at this part in the game, and if you don't use red and black, you're going to be horribly confused as we go along. Red denotes positive, black denotes ground in this situation. So on your multimeter, you have 2 matching leads, positive, negative, and also on your multimeter, you have a number of different settings down here. Next time I'm going to go over the difference between AC and DC current and stuff like that as we get into Ohm's law and how all that will apply. But for now we're going to be using this half of the multimeter, which is mostly DC measurements. So for the fun of doing it, I'm going to switch this to DC 10 volts now. And in order to measure voltage, what you do is you go in parallel with whatever you're doing. Remember the schematic, and show them the multimeter. Remember the schematic and get closer to it, Azzy. Okay, right there. So just go in parallel to measure voltage, and I'll show you that on this circuit. Let me go to one that's a little easier to measure. We'll go to here, up here. Now let's see if you can get both of these in the picture. So now what I'm going to do is I'm going to find the ground of the circuit, and I'm going to find the positive end of the circuit, and as you can see there's a voltage there as well. It's lower than the 6 volt source because these LEDs have a forward voltage drop, but I won't go into that either. But for voltage, put your meter in parallel with whatever you're measuring. Now I'm going to show you how to measure current, in which case you're going to need to put your meter in series with whatever you're measuring. So for that, you're going to bring power from the battery to the positive side of your multimeter, and then you're going to go from the negative side of your multimeter into the circuit, and you're going to switch it to an amperage setting. For me, I'm going to go 250 milliamp scale, and I'll again explain what that means later. But now I'm going to measure the current through this series circuit, and if Asley will come over here. So through here, as you come down, what you see here is we're measuring current, and this is with the multimeter in series, and I'm going to show you what the board looks like after that. So remember, voltage, parallel, current, series, and then also remember the different advantages and disadvantages of each of these circuits, because it'll be important. Asley, come here for a minute, because you're going to have to watch the board for it. Okay. So now that I've shown you that, we can move on. I'm trying to stuff a lot of information into one video. I'm sorry for that, but it's got to happen. Okay, so I'm going to grab this, and Asley, come as straight on with the board as possible. So in order to measure current through the series circuit, you're going to put the meter denoted by an M in this case, because that's what I want it to be. M will give you current because it's in series, and I stands for current. In parallel, you're going to be able to get the voltage across things. So if you put the meter in parallel, you can measure volts. Okay? So you need to remember that for future. Voltage, it will be in parallel, current in series, and then you need to know the difference between a series and a parallel circuit, because that kind of determines how resistances and various other things add up. So thank you for this video. I'm just going to tell Asley thank you, and then I'm going to tell you what's going to be in the next video. The next video is going to go over everything we've just done here, but it's going to be mostly math next time, and I'll have a couple of example circuits built for you. Next time will be Ohm's law, so that's what that'll be. The next video after that, I think I'm going to start going into the miracles of transistors, and then after that, what microprocessors are, what the different components and parts to them are. So I hope you enjoy the video. Again, I have to get some video editing software and it may be better, but just please bear with me for these first few videos. Thank you.